Hello and welcome to this video. Did you know that it is possible for you to create a program in Python that is capable of allowing you to input the atomic number of an element, that is the elements that are available in the periodic table from your chemistry lessons, and then the program will be courteous enough to generate for you more details about that particular element, such as maybe the symbol of that particular element, the name, the density, the atomic mass, and so on. So to be able to do that, hang along on this video and we'll take you through that exercise. But to start with, if you're here for the first time, please consider subscribing to the channel. Also like our videos, share them with your friends, click on the notification bell so that you're notified every time we release a new video. And now let's go on. So open your favorite Python editor. In my case, I'm using Google Colab, which is a platform as a service cloud provision by Google. And in this case, you don't need GPU, so you can just use the basic one. If you're using others such as a Jupyter Notebook or Spider, well and good, there's no problem. So the very first thing is to install the requisite libraries, especially if you're doing this for the first time. And the library that we're going to use here is known as periodic table. So periodic table is a library that contains all data structures that you need to work with elements in the chemistry periodic table. Now, when we talk about this periodic table, it gives you access to so much information about the various elements that exist, and you can be able to even perform more manipulations than we're even going to do in this particular video. So if you would like to know more about the periodic table and how you can be able to use it, especially if you are doing projects that relate more and more towards the various elements that we know, or maybe you are a chemistry researcher and you want to use Python to perform some of your data analysis, then I believe this is something that you can pursue and you can research more on the periodic table library. But now, for beginners who just want to know how you can be able to do that, you start by installing periodic table. If you install periodic table, then you run your cell. If it exists, it will tell you that requirements is already certified. If it doesn't exist, then it is going to install the requisite libraries for you. After you install, just like any other Python program, you need to import. So you import periodic table. Please be cautious about what we call case sensitivity. Make sure that you are using the right case for your wordings of the periodic table. Then after you do that, define a variable known as atomic number. And this variable known as atomic number is the one that will house the number that you input. And in this variable, we assign it a value. And this value will be an integer. And now this value is not static. It's something that we are going to input. That is why we're using the function input here. So it will prompt us to enter the atomic number. After that, we are going to enter the atomic number. Once we enter this atomic number, what it is going to do, it is going to create a variable known as element and navigate through the library known as periodic table and try to access the element that contains that particular atomic number that we have entered. We could enter any atomic number that you know, and then we're going to try with several of them and we see how it behaves. So after it has looked through the periodic table library and it has discovered your element, then what will it do? It will first print the number that you have entered, just for purposes of you knowing what you have entered. Then it will access the element or table function, print out the symbol of that particular element as it appears in the periodic table. Then it will go ahead and print for you the name of that particular element using the element.name function. And then it will go ahead and print for you the atomic mass of that particular element using the element.mass function. And then finally, it will print for you the density using the element.density function. You can be able to add more elements or more properties that you want to print out by just putting this print function and then in brackets, you put the string that you want to print and then the function that will print that particular string. You can equally remove some that you may not desire here. For example, if you don't desire the atomic density, you can just comment by just putting a hash sign and you're able to comment it out. So once you have done that, you can now go ahead and test whether your program is able to do what you want it to do. And to test, you just press Shift Enter, and then it tells you to put the atomic number, apply with the number 11, and then it will tell me that I have inputted atomic number 11. Symbol is Na. The name is sodium. The atomic mass is 2.98977, and the density is 0.971. Let me try with another element. In this case, let me input something like 21, and it will tell me that this is an element known as stadium. The symbol is this one that you can see here, the mass and the density. Let's try it one more time. And in this case, we input an element such as 40. And once we click enter, to tell us that this is an element known as zirconium. The mass is there and the density is there. And you can see that now with these figures, having known the mass and the density, if you wanted to go more into data science and data analysis of these elements, you can be able to take these figures now as inputs and do some manipulations with them. So I believe this video has provided you with a hack that perhaps you never knew. And that marks the end of the video. Please consider subscribing to the channel, like our videos, and click on the notification bell, and as well share our videos with your friends. Thank you so much.